Yeah, good morning all. Now myself, Dr. Praveen, Associate Professor in School of Computer Science and Artificial Intelligence in SR University. Now today, I will explain searching algorithms in data structures. We have two algorithms are there. One is linear search, another one is the binary search. Now the main objective of searching is to access the elements efficiently and effectively. So in this video, I will explain linear search with a program with time complexity, as well as binary search with a program as well as time complexity, and what are the differences, which is the best searching algorithm in above these two. Yeah. Now the linear search is a good searching algorithm and easy searching algorithm. This is the sequential search algorithm. We have to search elements linearly. When we store some data elements in the array, now our searching element, whether it is available or not, first we have to check. If it is available, then you found into the element. Otherwise, the I value will be incremented by 1. So in this method, every element within the input array is traversed and compared with the search element. Okay, element to be found. If match is found in the array, the search is said to be successful. If there is no match found, the search is said to be unsuccessful and gives the worst case time complexity. So already we discussed time complexity in our previous videos. Best case analysis, average case analysis, and one more is the worst case analysis. So we have 10 elements are there. Now our element is comparing with the each element. Suppose our element is not available in the set. So we spend 10 milliseconds. These are the wastage. So that is called the worst case time complexity. Now coming to the algorithm, we start from the 0th index of the input array. Compare the key value within the value present in the 0th index. So if you want to, this is the way you want to write here. Okay. Now this is the 0, 1, 2, 3, 4, 5, 6. So total n equal to 11. Okay, now the elements are 10, 20, 3, 70, 54, 9, 6. We assume. The key element equal to 70. We assume. Now we have to search the 70. Start from the 0th index. Now this is if a of 0, a of I. First you take the a of I equal to key element. This is the condition. Now what is I value? I equal to I value equal to 0. I value equal to 0. A of 0. 10 equal to 70. This is the first step. Start from the 0th index of the input array. Second input array. Compare the key value with the value present in that 0th index. Now 10 is equivalent to 70. No. This condition is failed. So when this condition is failed, then I value will be incremented by 1. Now go to the step 2. If the value matches the key, return the position at which the value will be found. So now here that is not equivalent to go to the third step. If the value does not match, so you observe here 70 is 70. Where is the 70? No, this is the 70. 70 equal to 10 because a of 0 is 10. 70 equal to 10. Now this is not match. So go to the third step. If the value does not match with the key, compare the next element in the key array. What is the next element? Now this is the next element. Okay, 20 is the next element. So I will be incremented by 1. I plus plus. Now I equal to now 1. So what is A of 1? A of 1 is, here you write, A of 1 is 20. 20 equal to 70, it is not equivalent. 20 is not equivalent to 70. So again go to the third step. In third step, if the value does not match with the key, compare the next element in the array. Okay, now the next element. Where is the next element here? This is the next element. 3 is the next element. So next element, now 3 equal to 70, it is not also, it is also not equivalent. So again, the value does not match with the key element. Compare with the next element. Next element, what is the next element? 70. 70 equivalent to 70. So the second step, if the value matches with the key, return the position. What is the position in here? 3. Okay, the actually the number of elements are 7. 3 plus 1, 4. Fourth position, our element is available. So the repeat step 3 until there is a match found. Suppose we enter the 100. The key element is the 100. 100, is it available in the set? No. So now repeat the step 3, does not match with 70, does not match with 54, does not match with 9, now does not match with 6, because our key element is not available in the set. Our key element is 100, 100 is not available. So now, if the repeat step 3 until there is match found, so here there is no possibility to search the element. And if the element is available in the last position or other position, return the position at which the match was found. And step 5, if it is an unsuccessful search, so like 100 is the unsuccessful, print the element is not present in the array and exit the program. This is the algorithm. So we have a 5 steps. Everyone knows the algorithm. Algorithm is a step-by-step procedure to solve a particular task. So now the first step is 0th element is equivalent to the key element. We print the element. Otherwise, if the value matches with the key element, you print the position. If there does not match with the key value, you compare with the next element. Okay, suppose you repeat step 3 until your element is found, match was found. Otherwise that is a unsuccessful search, so your element is not available in the set. This is a linear search algorithm. Coming to this example, let us look at the step-by-step searching of the key elements. So 47 is an array using the linear. 47 is the key element. So now 47, first we always use, here we are use the for loop for I equal to 0, I less than n minus 1, I plus plus. If a of I equal to such, a of I equal to key element, then element is found at some position. So now the first one, the linear search starts with the 0th index. That is our step 1. In our algorithm already we discussed step 1. Compare the key element with the value in the 0th index. What is the 0th index here? 34. 34 equal to 47. So now here you observe here 37, 34 equal to 47. No, the condition is fail. When this condition is fail, the go to the third step does not match, then the comparison with next element. What is the next element? 10. Now go to the, now the key is compared with the value in the first index. Now you compare with these two elements. Is it matching? Yeah, now here you observe here, now the 47 is not equivalent to 34 and 47 is not equivalent to 10. Now the coming to the here, see this is also not equivalent, right? One second. Yeah, this is also not equivalent. So now the still 4710 making in the algorithm moves to another iteration, because coming to third step, step 3 is repeated for this example. Now here the step 3, the next element 66 is compared with 47. So the 34 is not equivalent and 10 is not equivalent. Now the 66 equivalent to 47. You compare with this is also not matching with 47. So again, in algorithm step 3, we move to the next comparison. So now the element third index 27 is compared with the key value 47. They are not equal, so the algorithm pushed forward to check the next element. So here, this is you observe here, this is not equivalent, this is not equivalent, this is not equivalent. Now this is also not equivalent. So compare the element in the fourth index of the array 47. The key element is also 47. It is figurated the both elements match. Now the 47 position in the 47 is a present 4. So the element is here. Coming to this one, this is equivalent. Both are equivalent. The output achieved in is element found at fourth position, fourth index. Or if you start with actually here the start with 0, 0, 4 plus 1, 4 you write like this, 4 plus 1 in fifth index. Our element is available because total number of elements are 8. So in fifth position, our element is available, right? This is the linear search. And analysis of the linear search, we observe here, actually three cases are there. One is best case, average case, and worst case. Linear search traverses through every element sequentially. Therefore, the best is when the element is found in the very first iteration. That is called, if the element is, for example, if the element is the searching element is 34, the 0th position is also 34, then the time complexity is big O of 1. Big O of 1 means it will take only 1 millisecond. So that is the best case analysis. The worst case of the linear search method would be is unsuccessful search. So in already we discussed 100 is not available in this list. So we want to search 100. So from 0 to 7, 100 is not available. So your element is unsuccessful. Such that does not find the key value in this array. It performs n iterations. Therefore, the worst case time complexity of the linear search algorithm would be big O of n. So finally, we have to return the time complexity of the linear search is big O of n. Right? This is about the linear search. And coming to second searching algorithm is the binary search algorithm. It is very important. Now, for example, see observe here. Now 47, how many times we have to search? So the first case 34 is not equivalent to 47, one iteration, 10 equivalent to 47. This is the second iteration. And coming to 66 is not equivalent to 47, third iteration. 27 is not equivalent to 47, fourth iteration. In fifth iteration, our element is available. So coming to our time complexity, it is called the 5 milliseconds. Okay, we assume. Sorry, 5 ms. Now we have to reduce the time complexity by using the binary search. By using the binary search. So now analysis is 5 iterations. Now binary search is the fast search algorithm with runtime complexity is big O of log n. Big O of log n, or big O, actually it is called big O of n log n. This such algorithm works on the part principle of divide and conquer. Principle of divide and conquer means now the set can be divided two partitions, right? In the so middle element, compare with the first, the element, our searching element is compared with the middle element. If it is equivalent, then the element is found, and that is called the only 1 milliseconds it return big O of 1. If it is not equivalent, if the element is less than, because first we take the sorted set, and if the element is less than mid element, only we can check the first partition, first subarray. Otherwise, if the element is greater than middle element, we can search in second set. Okay, it means uh, based on the mid element, before mid element elements are called one set, after mid element elements are called another set. So now you should follow the divide and conquer rule. Since it divides the array into half before searching, for this algorithm to work properly, the data collection should be in the sorted form. Binary search looks for the particular key value by the comparing the middlemost item of the collection. If a match occurs, then the index of the item is returned. But if the middle item has a value greater than the key value, the right subarray of the middle item is searched. Otherwise, the left subarray is searched. This process continues recursively until the size of the subarray reduces to 0. So now here we have some elements are there. This is the set of elements. So middle element is the 27. How we search? How L equal to 0, high equal to n minus 1, right? And m equal to L plus h by 2. L equal to s by 0 plus, observe here, 0 plus 9 by 2. So the value written 5. Actually 0 plus 9 by 2, so that value is the 4.5, but we consider as only 4. So the fourth index, what is the fourth index? 27. Now our searching element, for example, search element key is 27. We assume 27 equal to 27, yes, the element is find out. Next, now the key element is 14, we assume 14. So now 14 is less than 27. So this is available in the first set. Okay, now the key element is suppose 42, we assume 42. Now 42 is greater than 27. Observe here, 42 is greater than 27. Then we can search in this set. Okay, there is no need to search in the first sub array. Okay, this is the process of the binary search. Now coming to algorithm, all of you read one. How many steps we have? 5 steps. First, what is the step 1? Select the middle item in the array and compare it with the key value to be searched. If it is matched, return the position of the media. Return the position of the media. So now in our example, now the middle element. How can we find out the middle element? Middle equal to low plus high by 2. Now previous example, low value equal to 0, high value equal to what is high value? Some 9, 0 plus 9 by 2, so 10 by 2, sorry 9 by 2, so 4 is the middle. So A of middle is 27. A of middle is 27. If the key element is also 27, then the first step is successfully matched. If it is matched, then return the position like median position. And otherwise, go to the step 2. If it does not match the key value, check if the key value is either greater than or less than the median value. If it is does not match, so 20, for example, our element is 19 or something, our element is the 19. 19 is not equivalent to 27, right? Check if the key value either less than or greater than. Now here the key value is greater than our key less than our middle element, so median value. So now we move only left subtree, we can take a left subtree only. If the key value is greater than our median value, then we go to the right subtree. Now, this is about the step 2. And step 3, if the key is greater than, perform the search in the right subtree. But if the key is lower than the median value, perform the search in the left subtree. Already we discussed this step 3. Okay, based on the key value and based on the median value, either we move left subtree or either we move right subtree. So you remember the key value is greater than mid value, then move to the right side, right subtree. If the key value is less than median value, then we can move to left subtree. Okay, now this is the process. Now we continue step 3. Step 1, step 2, step 3. Repeat step 1, step 2 and step 3 iteratively until the size of the subarray becomes 1. Okay, actually divide and conquer. We can divide a single element. Now step 5, if the key value does not exist in the array, then the algorithm returns an unsuccessful search. That is called the worst case analysis, worst case method. So this is about the algorithm. In this algorithm, we have 5 steps. The step 1, first one, middle, we find out the middle element. Middle element is compared with the key element. If it is equal, there is no problem. We can print the element. If it does not match, then we search either the key element is greater than or less than the key middle element. If it is less greater than, then we move to right subtree. If it is less than, we move to left subtract, right? Okay, we can repeat these iterations until single element. Okay, now here we have an example. We need to search the location of the value 31 using the binary search. Okay, total number of elements are 10 elements we have. So that first element is reside in the 0th location. Here 0th location. The last element is reside in the 9th location. So now mid equal to L plus H by 2. L plus H by 2. 0 plus 9 by 2. So that is 4. So fourth element is the 27. Now 27 equal to 31. No, condition failed. Then now 31 is 31, sorry. 31 is greater than 27. Then we can, you observe, 31 is greater than 27. Then only we can consider this part. This part. Now we compare the value stored at location 4 with the value being searched, that is 31. We find that the value at location 4 is 27, which is not match, as the value is greater than 27 and we have sorted array. So we also know that the target value must be in the upper portion of the array. Upper portion of the array means that is called right subtree, right sub array. So right sub array, the elements are 5 to 9. Right sub array, 5 elements are 5 to 9. So now here, this see observe here. Now there is no need of this set. Only we consider this is the low. Sorry, this is the low. This is the high. Now mid equal to 5 plus 9 by 2. Okay, 7. 14 plus 7. Now seventh element, we consider seventh element. Now this is the seventh element. Our new mid is a 7. We compare the value stored at the location 7 with our target value 31. 31 equal to 35. No, condition fail. 35 is the median value. 31 is less than 35. So we use the left subtree or left subarray only. So this is the low. Low is not changed. High equal to median minus 1. High equal to median minus 1. So the value stored at location 7 is not matched. Rather, it is less than what we are looking for. So the value must be in the lower part from the location. So Now we have a two elements. This is low and this is high. 5 plus 6 by 2. So 11 by 2. So the value will 5. That is the median value is 5. So our searching element is also 5. So 31 equivalent to 31 is possible. So 31, we compare the value stored at location 5 with our target value. We find that it is a match. We conclude that the target value 31 is stored at location 5. So this is the binary search. Okay, in linear search we have taken more cost and more time complexity than binary search. In binary search is the best algorithm, efficient algorithm. Now, compared to the analysis of the binary search, the input array is searched iteratively by dividing into multiple subarrays. After every every iteration, that is called the every unsuccessful iteration. Therefore, therefore Therefore, the recurrence relation formed would be of a dividing function. During the first iteration, the element is searched in the entire array. Therefore, length of the array equivalent to n. In the second iteration, only half of the original array is searched. Hence, length of the array is n by 2. In the third iteration, half of the previous subarray is searched. Here, the length of the array will be 25%, that is called n by 4. Similarly, in the ith iteration, the length of the array will become n by 2, n by 2 power I. To achieve a successful search after the last iteration, the length of the array must be 1. Hence, n by 2 power I equivalent to 1, n equal to 2 into I, log n equal to log 2i, 2 power I, log n equal to I into log 2. So, I equal to log n. Okay, log n. So, the time complexity of the binary search algorithm is big O of. Big O is a representation of the time complexity. Big O, omega and theta. Now, always we have to use the big O notation. Big O of log n. This is the time complexity of the binary search. Now, I want to explain the program also. So you observe here in all our videos, I explain the concept, explain the theoretical concept and time complexity as well as practical implementation. That is called the program. Wait few seconds. I will share the program also. Wait. Okay, wait few seconds. I will share the. Now, this is the program for linear search and binary search. Linear search here you observe here array, into size and target. And now left equal to 0, right equal to size minus 1, left less than or equal to right, middle left plus high, that is called low plus high by 2, and mid equal to target value, you print the mid value, and otherwise mid is less than target value, left equal to mid plus 1, we can search only right off, otherwise we can search left off, left. And this is the program for the all examples.